neither A or anything. So it was flat, 11 flat, which was developed in the year 1997, and it was running on a frequency band of 2.4 gigahertz. Okay, the speed was 1 megabyte and 2 megabytes per second. Okay, that was the speed for this technology. Then the new technology was invented, which is 802.11 B, actually A standard, but the B standard was the first to be created, and then A came later. So B, 11B, this standard here, was the first standard, was the second actually. So this was the second in the year 1999, and it was running at 2.4 gigahertz frequency band, and it used to provide 11 megabytes per second as the maximum. Okay, so it could run at 5, it could run at 6, and the maximum will be 11 megabytes per second. Because of its challenges of speed, the latest standard was formulated, which is 802.11a in 1999 still, which ran at a higher frequency modulation of 5 gigahertz and could give a 54 megabytes per second, okay, speed. So that standard was working, and then there was a need to combat some of the issues of these two standards. And some of the issues were addressed by bringing up a new standard, which was 802.11G in 2003, that ran at 2.4 gigahertz, giving the 54 or 54 megabytes per second. Now, in the making, the standard A and actually standard G was made to be a backward compatibility for 802.11b, and giving it a higher, much more speed for that regard, from 11 megabytes up to 54 megabytes per second. A new standard after all those standards were created, the 802.11n was being created, and this standard here was running or was developed in 2009, running at 2 frequency bands. Now, this standard mainly was created to provide what we call a backward compatibility of all these standards that we see here. Okay, it was provide a backward compatibility of the standards of all from A to B to G. Okay, and it could give us speeds of up to 600 megabytes per second. But there are challenges. There have been challenges with that kind of standard, and it does not truly give you the fully backward compatibility of all these standards A, B, G, because of the certain difficulties that happen with certain of the frequencies that are being used with the rest of the technologies there. So then we have other two new technologies. These are the 802.SC-Wave1 and SC-Wave2. These work being developed in 2013 and 2015 respectively, are running at 5 gigahertz and giving much more super speeds, which is 1.3 and 3.4 gigabits per second. So these speeds are much more higher than any other, and they are being used in technologies of the wireless wide area networks. So that is the table that is giving you the various standards, but also the showing the various speeds that are being used for the standard and which year of innovation or development. So that is for the wireless local area networks. We have to look at what we call the development of these standards, and the development of these standards, we really look at the various stages and the types of the various technologies that are being developed. We have talked about the 11A, the first generation, 11B also coming into play after the 11 flat being created. So let's look at this chart here that talks about the transmission performance and also time. So when you look at the high bandwidth of 802.11ag, which reaches 54 megabytes per second, and also the rates of the 802.11n that reach up to 600 megabytes per second, this is a cause because it can use MIMO technology. So what we see here is that we look at the standard. We can see the various standards here. For example, we see the standard of 802.11b standard, which runs at 2.4 gigahertz and has a maximum speed of 11 megabytes per second, having the encryption standard of the wired equivalence privacy encryption standard as being used for the encryption. So this standard here is being used for encryption in the 802.11b and given a speed rate of that. The next thing that happens within time that was the development of 11A and 11G, which run at 2.4 and 5 gigahertz ranges, each of them giving 54 megabytes per second. Now they have capabilities of having what we call the quality of service being implemented, and also having security encryption of WPA, okay, which is one of the privacy authentication security mechanisms. We shall look at all of these in detail as we move on for the security technologies. The third generation that saw 802.11 being developed, which uses what we call the multiple input, multiple output. It is also used in WiMAX and 3G for smart or for the connections in the smartphones to be connected. So what happens is that this high bandwidth and wide range coverage, it is used for the combination. Okay, it can go for up to from the 500 to 1,000 meters. That is for 802.11n. And much of the capabilities for transversing, it can be applicable for penetrating sometimes walls of houses, okay, unless they are really complex structures. We have seen this incident that happens in various regions here. For example, if you find that some of the network coverage is not good in your area, look at the house population in your area and what materials of those houses. For example, if you find the population, let me say for the densely populated areas here in Kampala, the houses are next to each other and are each having concrete walls. So the network signals, if they're not really at a higher point, just that this region might be in a valley, so that the signals are just put at the tower above them that are just penetrating down. If the tower is being put in a crossword, like the signals have to transfer from one house to another house to give access to the users in depth, this kind of area, you'll find that the area will have poor coverage because the signals will become much more weak and weak as they transverse from one building to the other building. But also, there are various technologies that are going to be deployed here, which we have the access control and also what we call the fit access points. So we shall look at the fit and the fat access point modes that are being used to work in the field. For the technologies that are being used to connect here, we shall look more in depth and we shall cover all that and much more aware, and this will be given out. All right. So that is for the development of the wireless area networks. But the advantages of, as we have already looked at the advantages, we have seen that there is high mobility for the wireless networks than the wired networks. There is much more flexibility, scalability, and economical, whereby there is a reduced cost. For mobility, we know that the users move a lot, and because of data needs, they need to be connected while not staying in the same place. So the wireless local network would enable them to access the data from various locations while they are on the move, which would improve the productivity of these users. There is flexibility. We have talked about flexibility, and flexibility mainly is kind of like enabling someone moving from, let me say, if we have a network that is totally connected with traditional cabling, flexibility is not so much easy in that kind of way. So if you have an old building, for example, without the original design, it would be difficult for laying cables, because what happens if you are a network engineer and someone calls you, gives you a call and say, hey, I heard that you're the one who studied networks. Can you please come to my office? And the moment you arrive, they will introduce you to the board that this is my friend who has done already network engineering, and they can help us build the network for this organization, and is counting on you. And when you ask them, they don't have the blueprint, or they don't have the structure plan for the building, and it's going to be really hard for you to design both for the physical and the logical network topologies for the network. And because you have to get possession of these two architectures designs in order to build your network, it will be so hard for you to deploy your network flexibly. So what happens? Wireless technologies do not need for you to then make this plan based on the architecture of the building mainly. You can physically locate the angles that you want to deploy the wireless access points and deploy them, which will be much more easier to deploy than when you're deploying a wired network. For scalability, it's about mainly not needing cables, and also recovering for the parts that we saw. There is what we call the link edgings. So you don't need that much cables to scale your network. You just need to plug another access point and you're good to go. This can be done in hotels where new extensions to the hotel is being done, but also even new clients. For example, the clients that are accessing hotels right now are not as much as the clients that were accessing the festive season. So what normally happens is that clients become much more at the certain times. So you need to boost up your network. And if you're using a layered network, wired network, you need to buy more cables, okay, to connect more users. But for the wireless network, it is easier to scale the network. Then for economical, we have looked at the no construction costs of buying cables and all that, and easier for deployment for that matter. So those are some of the advantages. And in the typical applications that we have for this network, we are going to be able to look at the stadium, news center, or exhibition halls, manufacturing, logistics. And it's at this point that I'll cover much of this part with a video. So I'm going to share a video with you guys that will help you see the various applications as they are being put out in the wireless network. So I think I'll first show you wireless networks being used in stadiums, okay, stadiums and also exhibition halls. So I'll show you the video, guys. I'll share the video with you.